All right. Hey, everybody, it's Cameron Pfeiffer here from .text. Today I'm going to be interviewing Daniel Quarnheim, who is a linguist that works on our team. And this is a little different than what we normally do. Normally, we do brief examples or code walkthroughs about using structure generation and language models. But if you like this interview style, please let us know in the comments because we can definitely do more of this. We've got plenty of people to interview, lots of people in the community to showcase. So let us know if you like that kind of stuff. But I hope you enjoy. Daniel's really awesome, and this was kind of a cool, goofy example of how to use context-free grammars. So thanks very much for watching, and I hope you enjoy.
All right, so hi everybody. My name is Cameron Pfeiffer at .text, and I'm here with Daniel Quarnheim, who also works at .text. He's kind of got a background in like natural language and stuff. So could you kind of give us like a little bit of an intro on like what your background is and the kind of stuff you find interesting?
Yeah, that's right. Hi, Cameron. Yeah, I'm one of the many Dans of .text.
We have too many Dans. We have too
I'm
many
Dan Q.
Mhm.
Right. Yeah. Yes, my background is in computational linguistics, like way before LLMs, and more. Well, I did a PhD in grammar formalisms, formal languages, automata theory, that kind of thing. And then I did a little bit of applied NLP, information extraction, voice bots, speech recognition. And then I got into LLMs and I learned about outlines and I applied for a job at .text because that was looked like I could combine my first love of automata theory with applied NLP. Like
Yeah, everyone's favorite first love, automata theory.
I hope my PhD advisor is hearing this.
We hope so too. Your PhD advisor.
To be honest, I never thought I would get back to working this like close to theory ever again.
Yeah, I mean, so we've talked a little bit about context-free grammars. Like, I'm still very much learning about them, and these are like kind of a, you can probably give a better introduction than me, but like the thing that I've been experiencing with them as like they're a tool for describing a lot of natural language and a lot of language in general, and they're incredibly powerful. And there's a lot of linguists who've been working on this stuff, and now all the linguists, like I was worried that linguists were going to be having some difficulty in the language model world, but it turns out being a linguist was actually a superpower when it comes to language models. And so that's a lot of the kind of stuff we work on here. So can you kind of give me the correct introduction to like context-free grammars?
Yeah, no, that's right. Like every linguist learns about context-free grammars, and I think the jury is still out on whether context-free grammars are even powerful enough for natural languages. But they're definitely more powerful than, for instance, regular grammars. So regular grammars are related to regular expressions. They're like the grammar and like you can write a grammar, you can write a regular expression as a finite state machine or as a regular grammar. And similarly for context-free grammars, you have an automaton, which is the push-down automaton, but you also have a grammar formalism, which is context-free grammars. And they are made up of rules. And you've probably seen parse trees where you have rules that branch off into, they have children. And they go all the way down to what we call leaf nodes. And I can show you a context-free grammar here. I loaded up sorry, that's not very readable. I loaded up the context-free grammar for the JSON specification. And okay, it's very simple. It has like a top level, we call that a non-terminal. It's the top level symbol. And a value can either be a dictionary, a list, a string, a number, one of the Boolean values, or null.
Okay.
So and this is a big disjunction.
Okay, so quotes here indicate that it is a literal, so it has to be the text true, the text false, the text null. Right. And then dict, list, and string are defined down below separately.
That's right. those are other grammar symbols. So value is defined in terms of all these other symbols. And this is the format of the Lark parser library. Lark is a popular library in the Python world.
Okay.
It is like if you want to look up grammars, you will probably find them in BNF, Bacchus-Naur format. This is very much inspired by it.
Okay.
You will find grammars for all sorts of protocols if you go through RFCs, and they all look a little bit like this. Sometimes, like, they will always have symbols on the left-hand side and then an expression on the right-hand side that tells you how to expand that symbol.
Okay.
In this case, to get a value, you get it from either a dict, a list, a string, and so on. So this is or, either or, like one of those alternatives.
Okay.
Like, and then if you want to do a list, for instance, you would have to have a literal opening square bracket and a closing square bracket, and in between, and now it gets a little confusing because these square brackets are not actual square brackets. They're just for grouping.
Okay, so in there,
yeah.
I should think of that as like a parentheses in like an arithmetic operation?
That's right. That's
Okay.
right. That's right. So how do you get a list in JSON? You take a value, and that can again be any JSON value, and then any number of more values. It has to be at least one.
Mm-hmm.
And if you're familiar with regular expressions, you know this asterisk for as many as you'd like.
Okay.
You take one, and as many as you like, you tack them on with commas.
Okay.
So value, comma, value, or value, comma, value, comma, value, as many as you like.
Okay. And this also makes it so that you don't have a trailing comma, which JSON doesn't support because
That's right.
It's
That's
only
a very
prepended comma value rather than value comma, because value comma will give you a trailing comma all the time. Okay.
That's a very good observation. Yeah, JSON does not allow trailing commas, which I sometimes wish it did, but it doesnn't.
Trailing commas are the perfect comma.
Yeah.
Like that's
Yeah.
the real comma that everybody should have that. SQL,
I know, right?
SQL, I'm looking at you. Please give me a trailing comma. My God.
I know, right? No, you can't have trailing commas here because every comma must be followed by another value.
Mm-hmm.
No trailing comma. And a dictionary is kind of like a list, except every entry is a pair, and a pair is made up of a key and a value. And the value can be any JSON object again, but the key has to be a string. And we define the string as an escaped string, which just means that raw backslashes are not allowed because backslashes have special meaning. Again, if you are familiar with regular expressions syntax, this is a regular expression.
Okay.
So at the leaf level, like if we go down in the tree all the way to the leaves, we have regular expressions.
Okay.
So you have like grammars are like supercharged regular expressions.
Okay.
Like with arbitrary nesting. That's the point.
Okay. So here, when we do this expansion, like inside of the value list, we have string as an available option.
Mm-hmm.
And then we
That's
have
right.
all caps escaped string.
Yeah.
Could we inline that by replacing the regular expression with string inside of the value?
Oh yeah, we could absolutely do that.
Okay.
What would happen then in Lark would treat it as an anonymous terminal.
Okay.
Which
Okay, gotcha.
which gives you like it gets a bit confusing when you have error reporting when your string does not conform to the grammar and Lark tells you why. It will tell you that like this anonymous terminal did not match your input. Whereas now that we gave it a name, it tells us exactly like it would tell us escape string failed. If it was inlined, it would be the same, but
Okay.
error reporting would be a bit worse.
Okay, so this grammar basically tells us the shape of JSON that is allowed. If something does not follow this set of rules, then it's not valid JSON.
That's right. That's right.
Okay.
And we could prove that. Like,
formal theorists coming in with proofs. No proofs.
no, okay.
I'm okay with proofs, but I think one way that we can prove it is that, like, the reason that at .text we're so interested in context-free grammars is that you can actually use them to generate. And so that, you know, when you're going through JSON, for example, you know what tokens are allowed. And a good example of this is JSON, where if you start out your string, it pretty much has to start out with a curly brace. And so you know that the first token has to be a curly brace. And then because you have a key with strings, your next token has to be a quote. And then you have to have the name of the key, and then an end quote, and then a colon. Those are all the tokens. You have to have those tokens. And so context-free grammars are the same, where you can kind of flexibly define the shape of a string and kind of let a language model fill it out. So can you kind of give me an example of, like, how you take this context-free grammar and get something interesting to come out?
Yeah, absolutely. Like first of all, let's see what happens when we just let our model, let an LLM just generate a string. Like here I have loaded the Phi 3.5 mini instruct model.
Okay.
And if I generate with that model and I give it a prompt, I actually have some fun prompts like prepared. I have this prompt. Sorry, I'm gonna make it a bit more readable.
Okay.
System, you're a helpful assistant. Please give me a short JSON description of a young medieval knight.
Okay.
And I'm gonna use this prompt to generate with the model. Just without any constraints.
Okay.
And it's just gonna, it will do JSON just fine because I told it to do JSON, but it won't do just JSON.
It gives us a bunch of other crap that we don't want.
Yeah, it will. First of all, it gives us this like markdown markup.
Yeah.
And after the JSON, it also tells us that this JSON object provides a structured description. We didn't want that, right?
Yeah, I wanted you to give me just the JSON so that I don't have to write a custom parser to get that
just to
out.
JSON. But did you feel like writing a prompt for that? Like, no, we shouldn't have to. Like, what we do is we build an index. So at .text, we have developed a way to enforce at runtime with basically no overhead the structure of any context-free grammar. So I'm going to build an index for the JSON grammar that I just showed you for the vocabulary of the LLM.
Okay.
So
because the vocabulary changes between language models, like Llama 2, Llama 3 has like 60,000-ish, and a lot of other ones have in like the low 100,000s.
This one is just 31,000, 32.
Okay.
Yeah. They get all the way up to like 250K with the Gemma models.
Okay.
So, and the index is basically a very efficient lookup table for a given vocabulary. And as you could, like, we can build an index in just a matter of seconds. And from then on, it's virtually no overhead. Let's use this index to generate. That's much better already. Just starts
cool.
out,
so no more gunk.
Like no fluff. No fluff. No fluff.
Oh, this is so cool. I love this. Like, I also love that it's like this is just a cool example. Like, so, you know, I think one of the things I run into a lot when I'm trying to explain what .text does when I'm working with structured text generation is like the phrase context-free grammars, like saying that is very dry. but like it's really nice to be able to see like, oh, okay, this is actually a really powerful tool that says like, this is JSON, like we know what the shape of JSON is, and then we can just turn off all this weird text that comes from the language model that we don't want when we're trying to build serious systems with language models.
Yeah, no, we don't want, exactly. And like, there was no introduction. It just started right with the opening curly brace. No fluff at the end either, just a JSON. No prompting required. You wouldn't even have to like to use that full prompt. You could just make a prompt. This make prompt is just to add the system prompt. So just describe. What would you like to describe?
Or I don't know. Let's say like describe a beach. Describe a beach. Let's just see what
in JSON.
In JSON, describe a beach.
Yeah, but we don't have to say in JSON because it will be JSON.
It must be JSON. It can't be anything else.
Sorry, it's not called make prompt. It's just called prompt. Oh, it gives us a string.
So this is because awesome. It can give you a string because it isn't required to start with a curly brace.
That's right, but we can force it to start with a curly brace. Let's try that. It's very simple. I don't know what the max tokens is here, how long it will go on.
Presumably we're going to get a nice description of beaches here. Yeah.
Overall.
Overall, we're coming to a close, I think.
Yes, very good. It was a string. So like you said, it is valid JSON because in the JSON grammar, any of those alternatives can be a valid object. It can be either a dictionary or a list or a string or a number, but we can have it start off with a curly brace.
Okay.
Let's see what happens. I have no idea. There you go. Okay, that's
okay. So this is okay. So this is like a general thing. I think we're finding with language models is like you can actually get pseudo like unstructured text that follows a format through the key, right? So when it creates the description field, it'll basically give us the same string as it had before. But now it's in a field that we can parse, right? It's like a thing that we can pull out and use in our code.
Yeah, and we could be a bit more specific in our prompt, like I don't know, describe facts about, or give us facts about.
Yeah, there we go.
Give me facts about, I don't know.
A beach on the Atlantic Ocean.
A beach on the Atlantic Ocean.
Yeah, maybe that's more specific. I hear that I live on the west coast of the U.S. So like
you do.
The Pacific is very cold and unforgiving. So I hope that the Atlantic is better. I've heard it's.
I live on the Atlantic, but it's kind of cold. But we have the Gulf Stream. So look, it gives us a very specific beach. It's not just any beach.
There we go. Yeah. So this is cool. Like,
does it check out?
Like it's making up these fields. Like this is valid. You can always parse this. Like that's the nice thing is like you can take this. You will always get a JSON object back, and like I just think it's so cool that you just kind of get free structure by passing in a pretty simple context-free grammar, right? That's not a complicated one.
No, it's not complicated. We've been working with more complicated ones, mostly for programming languages like I don't know, C, Python, Rust, etc. You name it. And those are those specifications are much longer, like let's say 100 rules, 100 grammar rules, like this, and we can handle them just fine. And but
to like put a finer point on that is like the context-free grammars are a really powerful way of describing the shape of text. And
that's right.
One of the things that's very, very powerful is you can do this with programming languages. And programming languages, language models can still screw them up sometimes. And you can always create syntactically valid code with no with no issues once you have a grammar defined for them. And so it's, you know, it's valuable to have context-free grammars that work for them.
Mhm.
Okay,
Right.
so can you show us? We have like a goofy little example.
We do,
Can you-
we do. I know what you mean. I know what you mean. Now, remember the JSON grammar. Sorry, I'm gonna make it a bit more readable. I made a little tweak. I call it the AJSON grammar, and the AJSON grammar differs from the original JSON grammar in just one little detail. Every string must start with the letter A, either uppercase or lowercase. So again, like this is a regular expression. And what it says is this character class, upper or lowercase a, must be the first character in every string.
Okay, so we have to see every time we see quote
Yep.
within a string block, it
Yep.
has to be quote a, lowercase a, capital A.
That's
Okay.
right. That's right. Now, what do you think is going to happen?
Well, I hope we're going to get a lot of A's.
Okay. Okay. Let's see what happens with the
So we
JSON index.
we have to do the index too.
That's right. We need to.
Oh,
this
you
will
have it.
fail. We need to. No, I haven't. I haven't. I need to build it, but that's just going to
Okay.
take just a second. A JSON index built from the A JSON grammar.
Okay.
2 seconds. There we go. And we generate away.
Yeah. Okay. So for people who are like watching this, we get age around 20 to 25, appearance, attire, armor. Like the language model has to start with an A. And so when it prints out an A, it has to figure out something that is likely after the A has been printed. So like once you have A under attributes, it knows that a reasonable thing to respond to is like agility, things like that. Accomplishments, you could have achievements, awards, allies, etc. So like this is just really cool. Like it shows you like how the language model like has to figure it out once it's forced to print out an A.
And it all makes sense. I mean, that is not just gibberish. It is very relevant.
Yeah.
Like, very relevant abilities for a medieval knight. And
Yeah.
so the language model makes sense. So we just constrain the structure a bit.
Yeah, no, I really love this. Like, I thought when you you showed me this example a little while ago, and I just remember thinking, like, I love that you can have a serious structure and then play around with it a little bit because I love like goofy stuff, you know. And so like this is a great example of something goofy, right? Like in this example, it's like not super practical. Like it's not like you don't really want JSON schemas that where all the strings start with A. Right, that's like not a thing that you really need, but it does demonstrate that you can have like, if you need a particular structure, you can actually define that in your grammar. This is an extremely flexible tool for generating whatever you need in a structure that it's coherent with whatever your kind of application or need is. And so I think this should like show people how useful and interesting this stuff is. So
yeah, and this is something.
Oh, sorry, go ahead.
No, and I was just going to say, this is not something that you can do with a JSON schema, because this is basically unrestrained JSON. We're not providing a schema. We're asking the language model to come up with the field names on its own.
Yeah.
But we're restricting the format of the fields.
Right. Whereas in like outlines, for example, you typically would specify an entire schema. It knows the field names, it knows the shape, it can't print anything else out. But the context-free grammar lets you say like, oh, okay, this is the general shape of everything. Like, please give me that, which is cool. Okay, so thank you very much for showing me this example. This is really nice.
Thanks, Cameron.
I hope we can do some more
My
interesting
pleasure.
examples where we talk to the team members and say like get people to show us all their cool stuff, because like everyone on the team is really cool and super smart and stuff like that. So I appreciate you taking the time, and yeah, I hope you have a lovely morning, evening,
Thank you.
whatever it is. Yeah.
Well, yeah, that's the thing about a fully remote team, fully distributed. It's afternoon for me.
Yeah. No, I'm just waking up. It's 7:30 or it's 8 in the morning for me. So I've got my coffee and I'm slowly becoming awake. So cheers. Okay. You have a lovely day, Daniel.
Thanks, Cameron. Same to you. Goodbye.
Bye.
Take care.